An insurer offers policies for which insured loss amounts follow a distribution with density function given below. Customers may choose one of two policies. Policy 1 has no deductible and a limit of 4, while policy 2 has a deductible of 4 and no limit. Given the occurrence of an insured loss, calculate the absolute value of the difference between the expected claim payments under policies 1 and 2. So fx is given to be x over 50, x between 0 and 10. And let y be the claim amount under policy 1, z be the claim amount under policy 2. So y had an upper limit of 4 and no deductible. So which means that um, as long as the loss amount is less than 4, loss amount was x. So as long as x is less than 4, you get paid the full. So you get y is equal to x. But once it hits 4, that's your cap. Then you never get paid more than 4 because 4 is the upper limit. So when the loss is greater than or equal to 4, your payment is 4. So the payment is equal to the loss when loss is less than 4. So that's why y is equal to x in that upper part. And the payment is equal to 4 once loss is greater than or equal to 4. And z is the claim amount under policy 2. And so um, the in case of Z, there is deductible, and so they have a deductible of 4, so you get paid nothing when your loss is less than 4, and then once loss is 4 or more, you get loss minus the deductible of 4. So Z is equal to 0 when x is less than 4, and x minus 4 when x is greater than or equal to 4. So you have to find the difference between the expected amounts under policies 1 and 2, and we will therefore find E of y and E of z. So E of y, the fundamental formula is the integral of y fx from negative infinity to infinity, and y will be written in terms of x because fx is the PDF of x. So if we look at y, it breaks its definition at 4. So from 0 to 4, y is equal to x. That's why from 0 to 4, y will be replaced by x in this equation. And f of x is always x over 50 in that range. And from, so technically this should be negative infinity. The less than 4 part should be negative infinity to 4, but there is no loss amount, there is no x value when x is less than 0. So negative infinity effectively in this case is 0. So negative infinity to 4 would practically be 0 to 4 because the other part would just be 0. And the PDF in that range is x over 50 as mentioned here. Plus, and then similarly, the greater than equal to 4 is ideally from 4 to infinity, but since x ends at 10, so it would just be 4 to 10. And then in this case, the y value equals 4, so we substitute 4 here, and the fx is x over 50 as before. And to integrate this, we first need to multiply x with x, so that's x squared, so that integrates to x cubed by 3, and the 3 gets multiplied with the 50 to give you x cubed by 150 when you integrate, and from 0 to 4. And similarly here, the integral of x is x squared by 2, and the 2 gets multiplied here, so you get x squared by 100, and we already have a 4, and that's from 4 to 10. And when you substitute the limits, you end up getting 3.79 for E of y. Similarly, E of z is the integral of z fx, and this one is active only. So you see z is non-zero only when x is bigger than or equal to 4, and the final bound for x is 10. So basically this one is active only from 4 to 10. 4 from here, and the 10 cap is from here, and the z equals x minus 4 in that range. So substitute x minus 4 over here, and then f of x is x over 50 as before. And you multiply, and you get x squared minus 4x. And the 1 over 50 can be pulled out. So the integral is x cubed over 3, and the integral of 4x is 2x squared. And then substitute the limits from 4 to 10, and you end up getting 2.88. And we needed the difference between the two, the absolute value of the difference between the two, so that can be obtained by doing the bigger minus the smallest. E of y was bigger, E of y was 3.79, and E of z was 2.88. We end up getting 0.91. That is choice D.